Lately, I have been thinking about exploring 3D graphics again. I have already made some games using pseudo 3D techniques before, like raycasting, parallax, sprite scaling, and others. I have even tried to build a 3D software renderer myself, all in Python, and almost always using Pygame. Performance has been a recurring concern and a limiting factor, which is why I'm constantly looking for more efficient methods, algorithms, and tricks to speed things up. For example, using Numba, which performs just-in-time compilation and can reach performance levels close to C or C++. So in a way, I was using a type of acceleration, but it was on the CPU. Anyway, testing Pygame's limits is fun. But for real 3D graphics, hardware acceleration is a sensible path if you want to do anything even slightly advanced. In many cases, it's practically mandatory if you want to achieve decent frame rates at resolutions higher than something like the Game Boy. It is possible to use OpenGL with Pygame through libraries like Piglet, ModernGL, or ZenGL, but they all seem a bit complex to work with, especially since OpenGL is a relatively old standard and not exactly beginner-friendly. I even checked out some ZenGL demos, which is the library most compatible with Pygame, allowing games to run in the browser, but I found it a bit too complex, not very intuitive, and perhaps a bit limited. At least I didn't find any demo that really impressed me, though maybe that's just my own ignorance. So looking for something a bit simpler than raw OpenGL, I started experimenting with Raylib, which is also compatible with Pygame, meaning I could still run my future projects in the browser. Raylib, much like Pygame, is a framework that can be used to create games and applications. It provides many functions that make life easier for developers and game creators without being a full-blown game engine. The library itself is written in C, but it has Python bindings, meaning the C functions are accessible through Python. That's actually quite common in Python libraries that need a certain level of performance. Pygame works in a similar way. Most of its rendering functions are written in C to make rendering faster. So what's the big difference between Pygame and Raylib? Pygame is essentially a wrapper around SGL2, simple direct media layer, and performs most of its rendering on the CPU, meaning it's mostly software rendered. Raylib, on the other hand, implements its core rendering functions using OpenGL as the default backend, which means it uses hardware acceleration and has native support for 3D graphics and shaders, much faster than software rendering. At first glance, Raylib might look a bit more complex than Pygame, but it actually is quite simple, and if you are interested, I highly recommend the tutorial from the Clear Code channel. It's a long video, but it truly explains how to use Raylib's main functions, and by the end you will have a solid foundation on how to create both 2D and simple 3D games. After getting a basic understanding of Raylib, I got curious about how its performance compares to Pygame's in simpler games, like my previous projects, just to get a sense of what new possibilities it might open. So to start, I made a simple benchmark where thousands of circles are drawn on the screen, one version in Pygame and another in Raylib. The code is almost identical. The main difference lies in the begin drawing and end drawing functions, which mark when a frame starts and when it ends on Raylib. And to my surprise, the Pygame version performed about the same, or even slightly faster. It turns out that this isn't the best way to compare the two libraries, since apparently circles and simple geometric shapes are generated with CPU help in Raylib. It calculates the vertices on the CPU, then sends them to the GPU for rendering. Raylib only starts to show a real advantage when the circles get quite large. So I made a new test, this time using sprites instead. Similar to the circle test, scaled, colored, and moving around on the screen. Now we can clearly see a significant performance difference between Pygame and Raylib. Raylib is about 3 times faster here. While Pygame struggles to stay in double-digit frame rates, Raylib easily maintains 60 FPS, and that gap widens if the sprite size increases. With that, I felt more confident about trying to recreate one of my previous projects using Raylib. The project I chose was Parallaxcraft, where a voxel world is drawn on the screen using scaled layers, creating a parallax effect that I found really cool. I got curious to see how that effect would look like using real 3D graphics, but still rendering the world as 2D layers. In Raylib, I need to create a GPU texture for each layer, but since each layer is built from tiles of different block types, it needs to be generated on the CPU using what Raylib calls images, which, as far as I understand, are roughly equivalent to Pygame surfaces. Once a layer image is ready, I can convert it into a texture that can be rendered on the GPU. If I want to modify a layer, say to remove or add a block, I first have to convert the texture back into an image, make the desired changes, and then turn it back into a texture again. You also need to set up a 3D camera, which Raylib conveniently provides ready to use. I just need to update it with the player's current position every frame. This time though, I made a first-person camera, unlike with my Pygame version. One small problem I found with this camera is that I cannot easily change the render distance, but this works fine for now. To draw the layers on the screen, I create quads that use the textures. Each quad has UV coordinates for every vertex and 3D positions for where each vertex should appear on the world. Little by little, I added the same features I had in my Pygame version, with some small improvements, like the skybox. In Pygame it was just a flat texture sliding from side to side, but here it's a giant cube surrounding the entire map. The result you are seeing on the screen now is basically true 3D, with correct perspective. The only slightly weird part is when you look down and see the space between the layers. But for distant blocks, it almost looks like a regular Minecraft clone. To make it more convincing, maybe I could render nearby blocks as real 3D cubes and keep the layered rendering only for distant blocks, kind of like a level of detail system. Overall, I found it really interesting to work with Raylib. The minimalist documentation, presented as a cheat sheet, is quite easy to use, though I did miss more detailed explanations of how each function works. For that reason, I ended up using ChatGPT quite a lot, usually describing what I wanted to do in Raylib or the problems I was running into. It often suggested functions or snippets of code that worked surprisingly well in most cases. As for running the game in the browser, it's basically the same process as with Pygame, using Pygame. Super easy. The only issue I ran into was with mouse capture, which sometimes results in nonce in mouse delta. But this was solved with a different command when packaging it up. The biggest advantage compared to my Pygame version is definitely performance. Here I can get a great frame rate at 720p resolution, while in Pygame I had to use 120p to get comparable performance. That's roughly 38 times fewer pixels. If you're looking for an easy way to learn 3D game development or make more advanced 2D games, I think Raylib is a great option. But if you just want to make a simpler 2D game, I still think Pygame is the better choice. It has more detailed documentation and a larger community, which makes it much easier to find answers and get unstuck. I hope you enjoyed the video. If you like to see more projects on the channel using Pygame, Raylib or maybe even Godot, leave a comment and subscribe. Thanks for watching and until the next time.